Hi Year 12, this is our fourth lesson for the topic of single variable statistics. In this lesson we're going to look at measures of spread. So far this topic we've covered types of data, organising data, displaying data and measures of central tendency. Now to accurately describe a data set we need to measure its centre, which we looked at last lesson, but also its spread. And most commonly we use the range to determine how spread out the data is. And that's simply the maximum value take away the minimum value. So here's an example. Find the range for the data set 2371499. The maximum is 99, the minimum is 1, and so the range is 98. Now a set of data can be divided into 4 quarters by using the lower quartile, which is Q1, the median, which we covered last lesson, and the upper quartile, Q3. So let's find the upper and lower quartiles of this data set 1, 2, 5, 9, 3, 7, 2, 0. Firstly, we need to put that data set in order. So it is 0, 1, 2, 2, 3, 5, 7, 9. And we're going to work out the median. So crossing off from each side into the center, we find that we have two centers, 2 and 3, and the median is going to be halfway between those two, which will be 2.5. Now to find the lower quartile, we look at the lower half of the data and we just work out the median of that lower half. So crossing off from either side, again we have two middles, and halfway between them, or the average of those two centers, is 1.5, so that's the lower quartile. Now let's look at the top half, 3, 5, 7, 9. Again we have two centers, 5 and 7. The average, or the center of those two, is 6, so the upper quartile is 6. Now I want to look at another example because the median's never included when we're working out the quartiles, and this didn't occur in the previous example, but it will in this one. Find the upper and lower quartiles of the data set 8, 2, 4, 3, 5, 2, 5. So again, we'll start by putting those in order. 2, 2, 3, 4, 5, 5, 8. And crossing off from either side, this time we have a single center, so the median is 4. And I'm going to start by crossing that out. So when we go to work out our lower and upper quartile, we're not going to include that 4. So just looking at the bottom half of the data here, the middle is 2, so our lower quartile is 2. And looking at the upper half of the data, the middle is 5, so the upper quartile is 5. The interquartile range is slightly more robust than the range that we calculated earlier because it's not going to be affected by outliers. Here's the formula. Interquartile range is the upper quartile take away the lower quartile. So this is the question we did right at the beginning of the video. Find the range for the data 2, 3, 7, 1, 4, and 99. And we worked out that the range was 98. Now let's work out the interquartile range. So put the data in order. Crossing off from either side, we have two middles. So the median is 3.5. Looking at the lower half, the lower quartile is 2, and the upper half, the upper quartile is 7. So our interquartile range is 7 take away 2, which is 5. Have a look here. The range is affected by that outlier of 99, but the interquartile range is not. We can also use the calculator to find the upper and lower quartiles, and it's in the same menu as the median. So let's enter stats mode and then enter some data. Remember to press AC. Then shift 1 for stats to open your stats menu. And we want 5 for min max. And have a look here. We have quartile 1 sitting there at 3 and quartile 3 sitting there at 5. And it won't give you the interquartile range, you'll have to work that out yourself. But 6 take away 1.5, the interquartile range is 4.5. Now a 5-number summary is a set of 5 statistics that summarize a data set. And the 5 numbers are the minimum, the lower quartile, the median, the upper quartile, and the maximum. And all 5 of those statistics appear in that menu that we were just using. So let's write a 5-number summary for this data set here. 1, 4, 4, 7, 8, 9, 11. All right, minimum and maximum, pretty easy to work out. So minimum is 1, the maximum is 11. Now let's work out the median. So crossing off from either side, 7 is the median. Now remember, we're going to knock that one out of the data set before we work out the lower and upper quartile. Looking here, the lower quartile is 4, and the upper quartile, it's 9. The reason that we're so interested in the 5-number summary is because we use it to draw a box plot, and this will help us display the data. So here's the 5-number summary we just worked out. Minimum is 1, lower quartile 4, median 7, upper quartile 9, and the maximum was 11. Here's the box plot. Have a look. Here's the minimum and the maximum, and then we draw a box around the middle 50% of the data. This is the lower quartile, the median gets its own line, and here's the upper quartile. Now importantly, each of these sections comprises 25% of the data. So you can see that's a bit compressed in here, but more spread out here. Now you will see other versions of this. Sometimes dots are not drawn on the end, and sometimes lines are drawn instead. But it means the same thing. Now, in addition to the quartiles, we can split data into deciles. So that means dividing it into 10 parts and into percentiles. And that divides the data into 100 parts. So for example, the 80th percentile, that would be the 8th decile, that's the score that's 80% above the other scores. And we use the cumulative frequency polygon to determine these statistics. So here's a cumulative frequency polygon, also known as an ogive. Remember, we covered this back in our second lesson. How do we use the ogive to work out the value of the 8th decile, or the 80% mark? We need to start by working out the total frequency. It tells us up the top that there are 40 students, so that's the total frequency, and we want 80% of that, which is 32. It's pretty easy from this point. We find 32, the cumulative frequency axis, go across until we hit the ogive and then down. So the 8th decile is 66%. That means 80% of students scored 66% or below. What about the 35th percentile? So that just means 35% of 40, which is 14. Find that here, go across and read off the graph. And it is 53%. Now, a more sophisticated measure of spread is standard deviation. This measures how far the average score deviates from the mean. There's a couple of formulas I want to show you. So here's standard deviation down here, but the square of standard deviation is variance. So let's have a look at this formula here. Here are the individual data scores, and here's the mean. So it's taking the difference or the distance between each score and the mean, squaring them so that we get rid of the pluses and minuses, adding them all up and dividing by how many there are. And then if we take the square root, we end up with standard deviation. And this is the symbol for standard deviation. So graphically, this is what it looks like. Here's a class of 12 students measuring their weight to the nearest kilogram. Here are the results, and these are the dots here. The mean here was 77. I've drawn that in as an orange line. And all of these red lines, that's the distance that each score is from the mean. So the standard deviation works out those distances, squares them to get rid of any negatives, finds the average of those distances, and then does the square root. And the calculator will also work out the standard deviation for us. So put the calculator into stats mode and choose 1 var and enter the data. Press clear, then shift 1 for your stats menu, and it's going to be in the same place as the mean. So in here, in variable. So there's our mean, there's our standard deviation, so press 3, and the standard deviation is 13.36. So that means on average, each of these scores is 13.36 away from the mean. So let's just have a look at that. Here we can see our mean. Now some of these data points are really close to the mean, but equally some of them are quite far away, aren't they? So on average, all of those little red lines, the distance from each of the points from the mean is 13.35. So range, interquartile range, or standard deviation, which one should we use? So our range is a very rudimentary measure. It's quick and easy, very susceptible to outliers. Interquartile range, it's better, it's unaffected by outliers, but it only uses two data points, the lower quartile and the upper quartile. So our most sophisticated measure is standard deviation. It uses all the data points. However, it can be affected by outliers because it does use the mean as part of its formula. Okay, that's it for this lesson. Our final lesson for this topic is on shape and modality.